In this video, we're going to talk about sampling distributions. Say you're a traveler and want to know what's the average price of an Airbnb in Vancouver. In practice, we don't usually have access to the entire population to answer inferential questions. However, for learning purposes, imagine we have access to a dataset representing the population of all Airbnb listings in Vancouver. If we look at the population distribution of Airbnb prices per night, we can see it's very right skewed. It looks like there's some pricey Airbnbs. From the population distribution, we can compute the population mean and find that the average Airbnb in Vancouver costs around $163 per night. Normally, we wouldn't have access to the population, so let's look at a sample of 50 Airbnbs, a sample distribution. The histogram still looks right skewed, much like the population distribution. The sample mean from this sample of size 50 is $156.22, slightly different than the population mean of $163. What if we take 1,000 samples of size 50? We can compute the mean for each sample and look at the sampling distribution of these sample means. Although it's still slightly right skewed, it's definitely less skewed than the population and is closer to resembling a bell curve. Also, if we compute the average of the 1,000 sample means, a result of $163.03 is almost exactly the population mean. What happens to our sampling distribution if we take larger samples of, say, size 300? The sampling distribution becomes even more bell-shaped and is less spread out. Now, if we compute the mean of the sample means, it actually equals the population mean. So, as the sample size increases, we notice two main things. The sampling distribution gets narrower, and each sample is more likely to have an estimate closer to the true population parameter we're trying to estimate. To quantify the spread of a sampling distribution and get an idea about the variability of our point estimates, we can use something called the standard error. It's the standard deviation of the sampling distribution of a sample estimate. As sample size increases, the standard error decreases. So far, we've used multiple sample simulation and sampling distributions to learn whether a sample can estimate the population parameter we're interested in. However, we run into a little problem with this approach. We only have one sample. This is because sampling is usually costly in terms of time and resources, and sometimes there may be ethical implications to sampling in a given study. In the next video, we'll learn how to approximate the sampling distribution to create a plausible range of values around our observed point estimate using a method called bootstrapping.